Hello friends, welcome to TextStudyCell. In this video, we will discuss how to save the last GPIO states in the ESP8266 flash memory. Let me turn on the first two lamps. Now only the first and second lamps are on. Now if I turn off the complete supply, you can see ESP8266 do not have any power supply right now. Now if I turn on the supply again, you can see the first two lamp automatically turns on according to the previous state. So ESP8266 can remember the previous state after the power failure. This is one of my previous IoT project where you can control these 4 appliances with the Blynk IoT App, IR remote, and also from the manual switches or push button. And you can also add Blynk Automation to this project to control the relays automatically with timer and room temperature. And now the NodeMCU can also remember the last GPIO states, so after restart the appliances will automatically turn on according to the previous states. So this is a very useful IoT project, and after watching the complete video you can easily add these new features to your any ESP8266 project. And you can also make the complete circuit without using any PCB, but I will always recommend you to use a PCB for any electronics project to avoid any loose connection. And now you can easily design professional PCBs for any electronics project using the Altium PCB designer software. Altium is the most trusted PCB designer software by all the big electronic companies. With Altium, you can easily search any electronics components, compare the datasheet, and it has lot of useful features which will save you a lot of time while routing any complex PCBs. There are a lot of tutorials available on Altium, and the user interface is so simple. You can easily learn this software and use it to design PCBs for your upcoming project. I will highly recommend you to download the free trial version of the Altium PCB designer software from the video description. These are the required components for this project. I have mentioned all the details in the description. Now you have to connect all these components as per the circuit diagram. In the circuit, you can see these switches are connected across the GPIO pins and the ground pin. Now if you use latch switch, then this switch 2, which is connected with the D3 GPIO, must be turned off during the booting process of the NodeMCU. Otherwise the booting process will fail. And if you use push button, then there is no such limitations. Now you have to configure the Blynk Cloud account for this project. As I said, for demonstration I am using one of my previous Blynk project. So if I go to template, I have used this template in my previous project. In the data stream, you can see I have created total 7 data streams, and I have also enabled automation for some data streams, and this is the web dashboard. And I have also added some Blynk automation to control the relays automatically with timer and room temperature. I have explained all these steps in my previous video. You can find the link in the description and also in the I button. After creating the template, you have to add the device. So you have to click on new device, then select from template, then you have to select the template name, and you can also give a name to the device. Now click on create. Now if I go to device info, then you will get all these details required for coding. These are the source codes for this project. You can download all these codes from our website iotcircuithub.com. Just visit the article link given in the description, then you can download all the codes from these buttons. After downloading all the codes, first you can use this code to get the hex code of the IR remote buttons. I have explained the process in my previous video. Then if you want to use push button, then you have to refer this code. You can see the button in the code name. And for the latch switch, you have to refer this code. Let me open the code for the latch switch. And for this project, you have to install all these libraries. I have also mentioned the version I have used for this project. Now to save the last GPIO states in the ESP8266 flash memory, I have used the preference library. For ESP8266, you have to install the preference library separately. For that, go to Sketch, then select Include Library, then click on Manage Libraries. Then here search for preference. From here, you have to install this library. After that, we have to update the template ID, device name and authentication token. So I will go to Blynk Cloud account and I will click here to copy all these details. Then here I will paste it. Then here you have to enter the Wi-Fi name and the Wi-Fi password. After that, you have to update the hex code of the IR remote buttons. Now if you have used the same circuit, then after doing these changes, you can directly go to Tools, select the board as NodeMCU 1.0 and select the proper port, then hit the upload button. Now let me explain how to use preference library to save data permanently in the ESP8266 flash memory. For that, first let me go to the void setup. In the void setup, first I am opening a namespace called relay state in read-write mode. The false argument indicates I am opening this relay state namespace in read-write mode. Then if I scroll down, I am calling this function getRelayState. Let me go to this function. In this function, first we are trying to fetch the data from the ESP8266 flash memory using this getBool function. Here relay1 is the key, and with this getBool function we are trying to fetch the value for this relay1 key, and if there is no such relay1 key, then it will return 0. So 0 is the default value. Thus we can easily fetch the data from the ESP8266 flash memory, and with the preference library we can store the data in the key value pair. I have already explained the data structure in this article, and again I will share this article link in the description. Now after getting the value for this relay1 key, we are storing it in the toggle state and accordingly turn on and off the first relay, and then we are trying to send a real-time feedback to Blynk server. We are doing the same process for relay 2, relay 3 and relay 4. Now let me go to void loop. So in the void loop, we are calling these two functions to control the relays with the manual switches and IR remote. First let me go to the IR remote function. So in the IR remote function, first we are checking if there is any data available from the IR receiver. Then we are comparing the data with the predefined value. Then we are changing the state of the relays. After that, we are storing the current state of that relay using this putBool function. And again, while storing the data in the flash memory, we have to store it in key value pair. So relay 1 is the key and toggle state is the value for this relay 1 key. Thus we can store the data in the flash memory. And if I go to manual control, we are doing the same process. After controlling the relay, we are storing the current state of the relay in the flash memory using this putBool function. So if you go through the code, you can easily understand. Still, if you face any issue, you can always let me know in the comment section. Now you have to configure the mobile dashboard. For that, open the Blynk IoT app, then go to device, and this is the device we have added. I have already configured the mobile dashboard during my previous video. You can find the link in the description. In the automation tab, you can see all the automation you have added. You can also turn off or on the automation and edit any automation. Here you can see I have given the supply to this circuit, and this blue LED indicates the NodeMCU is connected with the Wi-Fi. So I can control it with the Blynk IoT app, and I can use this button to turn off all the relays together. Now let me turn on the last two lamps. Now if I turn off the complete supply, you can see everything turns off. Now if I turn on the supply again, the last two lamps automatically turns on, and the NodeMCU will automatically connect with the Wi-Fi if the Wi-Fi is available. So this is a very useful IoT project, and I will really appreciate if you can support our work on Patreon. You can find a link in the description. And if you find this video helpful, then please hit the like button and share it with your friends. Don't forget to subscribe for more such videos. Thank you for watching. Have a great day.